Hello students, now today we are going to start a topic that is a 50 Hz AC power line. As you know, yesterday I told you that in our India there is a 230 volt RMS value, that is a root mean square value. Also you may have the frequency, that frequency is of 50 Hz in our India. But as soon as we are concerned with a foreign country, that is a USA, in the USA you have the voltage that is a 110 volt and the frequency it is of a 60 Hz. Okay, it is well known to you, all of you. This is the main indicated in the main line that all the parallel branches of an electrical equipment, the electricity is generated at a generating station and can be easily transmitted. Wherever the electricity has been generated, it is generated in that station and easily be transmitted. The alternating voltage is stepped up with a few kilovolt for a high voltage transmission line. Okay, this the alternating voltage is stepped up for a few kilovolt for the high transmission voltage transmission line. The line supply voltage, the line supply for the large amount of the power and a very small current and a less power losses. It is compared with a 230 volt line. Okay, at the distribution point of the home, the lower voltage is supplied by the step down transformer. Whenever there is a housing, the wiring has to become with a house, it is uses a step down transformer for a transmission. Then you are getting a 230 volt from that particular transmission line. Okay, the main in USA, as earlier I told you, it is 110 or 120 volt and the frequency in that you are getting a 60 Hz. Okay students, for a residential wiring we have the three phase. We have the three wire with a single line power line are used. The A and B are the phases and the third wire is grounded neutrally. Third wire, it is nothing but it is a neutral. When you are observing that thing, it is look like this. This is the system where you are getting the A, B and the neutral. Okay, it gives you 220 volt. This gives you from the ground again 220 volt, and best of all, when we combine all this one, you are getting the 440 volt. Okay, this much is the value which you are obtaining for a single phase power line. Okay, when for that particular residential wiring, the system cannot be used for three phase wiring. Okay, the color coding can be used for the different wires. As you know, the color, that is a red, blue, green and yellow. The four wire has been used for the electrician. Okay, for making the electric fitting, generally we are using this four wire, but red and the black wire, it is very much important, and the green wire which is used for grounding purpose. Okay, and the neutral, that is a blue, it is being used, and this is being used like this. This is the particular entrance for the water piping for the metal rod traveling into the ground. The purpose of the grounding is to make safety against the electric shock. The switches and the fuses are always phases are always in a phase line. So in this particular three wire single phase power line, you are using this one values. Okay, so it is very much simple students. Just you keep this 230 volt and the 50 Hz supply, 50 Hz frequency in our part. Okay, then comes the AC circuit. As you know that the AC circuit, it is an alternating circuit. This alternating circuit, the resistance R, it is inductive reactance, it is XL, and the capacitive reactance, it is XC. Okay, in an AC circuit, if the resistor is to be get considered, then it is nothing but it is considered as a resistance. Okay, if it is XL, then it is inductive reactance. If it is capacitance, then it is a capacitive reactance. And the three types of the opposition to AC. These are all the three types which opposing to that particular AC. While considering the opposition, the phases angle are also important. What is the phase angle? One should be lead, one should be lag. Okay, the leading, lagging and in phase. These are the three angles which has to be get considered when we are using this resistance are inductive reactance and the capacitive reactance. So how the leading and the lagging has to be get done? The total topic with a sine wave analysis that R, XL and the XC. Okay, these are XL and the XL. The total opposition of an AC circuit is nothing but it is the impedance. Okay, as you have learned this, the total opposition in AC circuit is the impedance, that is a Z. Now the very first, the AC circuit with a resistance only, we will see this one. Consider the diagram, this diagram. Okay, here the voltage source has been attached with a resistance R, and the whole path is being get connected with the voltage source with through a resistance, and the small current is going to flow from this resistance, and that's why the voltage and the current is equal. Okay. Consider the circuit having the resistance RO connected across the terminal, that is AC. Okay, it is a purely resistive circuit. The RMS value for the current, this current I is equal to V upon R. Okay, I is equal to V upon R when we are considering this current to be get flow from this resistor. Okay, the phasor diagram, whenever the phasor diagram has to be get considered in the resistance, the current and the voltage are always in a phase with each of the resistive circuit. It is happened only in the resistive circuit only. Okay. So here you may say that the phase angle, the voltage and the current same, it is in the same direction. It is in the same phase. Okay. Next, the AC circuit with the inductance only. Here you may consider instead of the resistance, you just attach the inductor and the current will be get flown like this. The inductor is the characteristics for that opposes any changes in the current. It is the ability of the conductor to produce the induced voltage when the current changes. When a coil is connected to that particular AC sources, the inductive coil provides an opposition to the current called as an inductive reactance. That inductive reactance in this circuit it is considered as a XL. Okay, the unit of that particular XL is nothing but it is a ohms. It is considered as a ohms, and this XL having a value XL is equal to 2 pi f into L. Okay students, this XL is having the value that is 2 pi f into L. When you are going to consider this one, it is a purely inductive circuit. Applied voltage V leads the current by 90 degree. It is a 90 degree. It leads the current by 90 degree, but applied voltage and the induced voltage, that is 180 degree out of phase. Here the current and the voltage, it is 180 degree out of phase. So the current is having this direction and the voltage is having that opposite direction, which is of a 90 degree phase. Okay. Since you will get the value for the current which is get flowing from this one, here I is equal to V by X into L. V by XL. It is the flow of the current in the circuit when the inductor has been attached with a voltage source. Then we are going to form the capacitance, AC circuit with the capacitance. Now we have studied the resistance, we have studied the inductor. Now the capacitor, instead of using that resistor or an inductor, we are going to connect the capacitor like this. The voltage source is connected with the capacitor, and as this capacitor is going to be get considered, the whole value of that particular capacitance. Here the capacitance has the ability to store the electric charges. It is a main important part of the circuit. The capacitance consists of a insulator, that is a dielectric between the two conductor, because the symbol for the capacitor which is shown, it is like this. It is symbol this type capacitor, and if it is an electrolytic capacitor, then the symbol will look like this, which is having the positive terminal and the negative terminal, which is indicated by the plus and minus. It is an electrolytic, it is a simple disc capacitor, but the both capacitor consisting of parallel plates. Due to that particular parallel plate, some electric charge is being get stored in between the plate, and due to that the insulator between the two conductors, the capacitor connected to an AC source, it provides the opposition to the current, which is called as a capacitive reactance. And that capacitive reactance in the circuit, it is indicated by Xc. Again, the unit for that particular Xc, it is ohms. When the current is going to be flow from the circuit, then you will be getting the value I is equal to V upon Xc. Okay, what is the value for the Xc? The Xc is nothing but you will get the value, that is Xc is equal to 1 upon 2 pi F into C. So this is the value for the inductive capacitance, the capacitive value, that is this one, the capacitive reactance 1 upon 2 pi Fc. Depending upon the frequency in the capacitance, Xc have any value from 0 to the infinity ohms. Okay, 0 to that particular infinity ohms. In a DC circuit, X is infinity since the capacitor acts as an open circuit. Okay, the inductive, it was a short circuited, but in the capacitance it is an open circuited for the DC. And in the, when we are going to consider the phase diagram, the voltage and the current is again having a 90-degree. It is a purely capacitor circuit. It leads the voltage by 90 degree. If the number of capacitors are connected in a series, the total capacitive reactance Xc, it is given by this one, Xc1 plus Xc2 plus this one. Okay, the capacitors are connected in series, the total capacitive reactance is given by this. If the number of the capacitors connected in parallel, the equivalent capacitive reactance is 1 upon Xc divided by 1 upon Xc plus 1 upon Xc plus 1 upon and so on. Okay, so these are the particular series and the parallel capacitive reactance. Then comes the impedance. The impedance considers the resistive, inductive and the capacitive circuit separately. If these three circuits are going to be connected in a one particular format, then the AC circuit, all the types are opposing and may provide the connecting between the R, L and the C. Okay, the total opposition is only the addition of resistance, the inductive reactance and the capacitive reactance, and the phase angle must be also considered. Here three, the resistive, capacitive and the inductive reactance, the phase angle is to be get considered. Since the total opposition for the AC is given by the impedance, and that impedance in this circuit it is indicated by Z. It is the Z. Okay, so that Z, it gives you Z is equal to V upon I. This V upon I, it is indicated by it with a square of R square plus XL minus XC. The unit for the Z, the impedance, it is in ohms. As we have studied, the I is equal to V upon Z for that particular Ohm's law. V is equal to I into R, and that's why you are getting the value I is equal to V upon R, which is shown in any circuit. When you are using the X value, that is the inductance value or reactance value, that is the XL minus XC, since Z is equal to X square plus R square under root of X square plus R square. Okay. Then consider the series reactance and the resistance, that is the RLC in series with any AC circuit. Now in this you have to consider the resistance, inductor and the capacitor. Also in some book this diagram is also drawn. It is also, you may observe in any book also. The resistor, inductor and the capacitor. Resistor, inductor and the capacitor, it is indicated by R, L and the C as it is in a series. Okay, as you know that whenever one is leading, one is lagging and one is phase, when the resistance is going to be get considered, it is in a phase. Okay, the next part it is leading, the next part it is lagging. So both the three values, now it is equal. Now we are going to consider the three value, and that's why the phase angle which is shown, it is like this. For the current, for the voltage, for the inductor, for the capacitor, one is leading and second is lagging. The inductor is leading, the capacitor is lagging. So when you are using this, it will form the angle. Okay, and that angle is nothing but it is the phase difference between the current and the supply voltage, that is the tan theta, that is XL minus XC by R, X by R, therefore theta is equal to tan inverse XL minus XC by R. So this is the theta that you will be getting, that is the angle, that is the phase angle. In a series current, the current I, RL and C are same. The VL, as I told you, the inductor, that is a VL, it will be lead by 90 degree, and VC, it will be lag by 90 degree. Here you may consider VL, you may consider VC, and here the current I. Okay, the VL, it is lead by 90 degree, it is lag by 90 degree. Okay, the VR is in a phase with the current. VR, always it is in a phase with the current. Instead of VR and VC, the XL and XC are plotted respectively. As we have studied the upper phasor diagram, the XL and XC, this VR, VL minus VC, it has been get indicated and forms the angle, that is called as a theta. Okay, here you will be getting the voltage, and here you are getting the VR value, and here you will be getting the VL minus VC. So from this particular phasor diagram, you clearly understood that one, from when the current is going to pass from the resistor, it is in a phase. When it is passed from the inductor, it will be lead by 90 degree, and when it is passed from the capacitor, it will be lag by 90 degree. Okay, so these are all the values which you have to keep in your mind. Then parallel reactance and the resistance. Again, we have to consider the resistance, inductor and the capacitor in the parallel in an AC circuit. Now the position for that particular inductor, capacitor and the resistance with a current value, you are going to form like this. The diagram which has been indicated for the parallel, it is this one, the voltage value. Okay, the resistance, capacitor and the resistance, inductor and the capacitor is being get connected like this. It is in a parallel, it is placed one after another. The resistance, when we are going to consider the current which is get flow, that is IR, from the inductor it is IL, from the capacitor it is IC. Okay, it is in a parallel with the resistance and the reactance. The phasor diagram for this particular circuit is like this. When the current value for the inductor and the capacitance will be shown in this circuit, the total opposition for the current impedance, that is Z is equal to V upon I. Since I is equal to V upon Z, you are getting the value. With the parallel circuit, the branches resistance and the reactance are added by the phasor. The total current, that is I is equal to I square R plus X, Ix square with a root. The whole root, that is I square R plus IL minus IC with a square, you are getting the value when the total current has to be get assumed. If we are going to separate the current, means from the resistance, from the inductor and from the capacitor, that's different current value has to be get formed, then you will be getting IR is equal to V upon R, IL is equal to V upon XL, IC is equal to V upon XC. So IR is in a phase, as you know that the resistance, whenever the current is going to flow from the resistance, the voltage and the current will be in a phase, and that's why you may say that IR is in a phase with a V. IL, the supply voltage by 90 degree, it lags the voltage by 90 degree in a parallel, and IC leads the supply voltage by 90 degree. Okay, so these are the three predictions which is going to be occurred in the parallel circuit. Okay, the theta is the phase difference between the current and supply voltage. The theta, the tan theta you will be getting, that is Ix upon IR, since IL minus IC by IR you are obtaining. The positive phase angle, which indicates the leading capacitive current, and the negative phase angle indicates the lagging inductive current, as shown in the above figure. Okay, when you are going to consider that particular figure, this figure gives you the different laggings and the currents. So these are the phase angle with one leading, one lagging with that particular IL and the IC, and the tan theta you will be getting theta angle, that is tan theta is equal to, you will be forming that particular theta, and the theta you are obtaining that Ix, that is a current, divided by IR. Okay, that Ix is nothing but the inductive current minus capacitive current. The inductive current minus capacitive current. Then comes the resonance. The resonance effect occurs when the inductive and the capacitive reactance are equal. Okay, when it will be occurred? When the value for the XL is equal to the XC, at that particular instant the resonance will be get occurred, and from that particular resonance you will be saying that how in an RLC, in a series, in an AC circuit, how the inductor increases as the frequency increases, but in the capacitive reactance decreases with the increase in the frequency. Okay, the at a particular frequency the reactance are equal. At one particular frequency the reactance will be equal, and that reactance we are going to find out. Okay, how it is going to find out? These reactants are equal but out opposite in a phase. These cases of equal and the opposite reactance is called as a resonance. It is very much important definition from the examination point of view. The frequency at which the resonance occurs in the resonant frequency, that is Fr, since at the resonance the XL is equal to XC, at one particular resonance you will be getting the value 2 pi Fr into L is equal to 1 upon the value for XC, it is 2 pi Fr into C. Okay, so now you have to make a cross multiplication for finding the particular frequency, that is a resonant frequency, that is a Fr. So you will be obtaining, you just go to this one place, here you will be getting the value, that is 4 pi square Fr square L into C is equal to 1. Since this value we have to find out, so you have Fr square is equal to 1 upon 4 pi square L into C. If we just get cancel this square, here we are obtaining the 2, here the square will be get cancelled, and here the root will be get obtained, and that's why you may say that 1 upon 2 pi under root of LC. This value, and yes, you can observe here, this value Fr is equal to 1 upon 2 pi under root of LC. You are obtaining this value, but this you have to show just below this equation. Okay, this you have to solve. Okay, so it is all about the resonant frequency which will be getting at this value in a series AC circuit. Okay, in a series AC circuit the XL leads by 90 degree and XC lags by 90 degree. As it is well known to you, the XL and XC are 180 degree out of phase. At a resonance, the XL and XC are equal and cancels each other, since XL minus XC is equal to 0. Okay, this XL minus XC is equal to 0. The only opposition to the current in the coil resistance, since therefore the series resonance, the current is maximum, the impedance is minimum, which is equal to the resistance. Okay, here in this circuit the resistance, inductor and the capacitor is being get observed, and at one particular resonant frequency this the series resonant curve has been obtained. Here this type of the curve F1, F2 and the frequency, resonant frequency is going to be obtained, that is a maximum value in the x-axis and in the y-axis. In the x-axis we are getting the frequency, and in the y-axis we are getting the maximum current. Okay, when one dot mark has been get occurred, you are getting the value for the current, that is a 0.707 Imax. Okay, that is a maximum current which is being get obtained. The frequency response for the series resonance, the current is small below the resonance and the rise in the maximum value at the resonant frequency. The current then again decreases to the small value above the resonance, and the phasor diagram for the resonance for the supply voltage and the current is in a phase, that is VR is equal to V. Okay, the phasor diagram for the series resonance has been shown like this. The VL value which is 90 degree, VC value it is lagged by this one, and VR value is equal to V, and the current it is in a phase. Okay, it is all about the series. You have to study the characteristics for the series resonance. The characteristics, the first characteristic, at resonance the XL is equal to XC, but there are ones 80 degree out of phase and they get cancel each other. The current is maximum at the resonance frequency. Okay, this is the second number point. The third number point, below resonant frequency, the XL value is less than XC. Okay, since the circuit is capacitive, and if the above resonance, the XL value is greater than XC. Okay, since that circuit is nothing but it is a inductive circuit, and if the resonant frequency, resonant impedance, that is a Z, is minimum, means Z is equal to R you are obtaining. At the resonance of the circuit, it is called as a acceptor, means it accepts all the value, and so that circuit is called as a acceptor circuit. Then the Q factor, which is formed by the circuit, the quantity of a figure of a merit for a resonant circuit is indicated by the Q factor, and that Q factor in that formation, it is given by XL by R. Directly you may write down this one, XL by R. It is a voltage across L or C divided by supply voltage, that is 2 pi FL into I divided by I into R. This I and I will get cancelled, and since you may say that 2 pi FL by R is equal to XL by R. This is the Q factor which is get obtained. Then the different bandwidths, the group of the frequency at a resonance, as 0.707 IM was considered. Here we are getting the 0.700 percentage of the maximum or more. It is being get considered at the bandwidth, and the tune circuit, the bandwidth which is occurred, that is a higher frequency minus lower frequency, or you may say that the total frequency, that is a del of F. The del of F is being considered, del F is equal to Fi divided by Q. You will be getting, since the sharp resonance at a high Q, it means the narrower bandwidth, and the lower Q, the greater the bandwidth. Here, for one particular Q value, for the second Q value, and for the third Q value, means the Q factor value, you are obtaining the different bandwidth, and in the X and the Y axis, you will be getting this one formation. Okay, so these are all about the bandwidth part which get affects. Here the application for that particular resonance, the most common application, it is used for tuning. The second number, the series resonance circuit provides the voltage magnification, and the parallel resonance circuit provides the current magnification. These 2 points is very much important. The series resonance circuit provides the voltage magnification, and the parallel resonance circuit provides the current magnification. Okay students, then comes a real power. This real power is nothing but in an AC circuit with a reactance, the current I supplied by the generated either the lead or the lag for the generator voltage. When the voltage, when the V and I are out of phase because of the reactance, the product of the RMS value V and I is called as a apparent power. Okay, the unit for that particular voltage, the unit, it is nothing but it is a volt ampere. Especially in this case, it is only the volt ampere. The real power, it is calculated by I square into R, where R is the total resistive component of the circuit, and I and V are in the same phase in the resistance. Okay, and whenever the power has to be considered, the unit for that particular power will be in a watt. Okay, that watt, the power P is equal to, you are getting the value V into I cos of theta. Okay, this is the real power I square R, that is VI into cos of theta. Theta is the phase angle between voltage and the current. Since the power factor cos theta is equal to R by Z. In a parallel circuit, the power factor, it is IR by IT, the total current, the total resistance, and total value. Then correcting the power factor, here whenever you are using this particular power value in a commercial use, the power factor should be close to the unity and the effective distribution. The inductive load of the motor may be result in a low power factor. To correct the lagging inductive component of the current in the main line, the capacitor can be connected across the line to draw the leading current from the source. Then the power factor may be brought to the unity. Means whenever you have that particular thing to be get attached, you have to attach the capacitor for making the power factor in a particular line. Okay, so these are all about the bandwidth, the power factor. Okay, Then the different problems have been given in your book. These problems you have to solve.